So to perform this, I have a series of wire brushes. I have a steel, a brass, and a nylon bristle. Now these are cheap. You can get a 3 or a 6 pack for like just a couple dollars. And if you've never used wire brushes for do-it-yourself stuff, or if you're just getting into it, these are a necessity. You'll use these, and these come in variety packs. Like I said, I've got steel, brass, and nylon, and they come in variety packs, and you'll use all 3 of them under different circumstances. I'm going to need some sandpaper to sand the copper contacts. I have some dielectric connector grease. This is $1.50 at any automotive store. Very cheap. There's more in here than what I'm going to need for this repair. And a small set of screwdrivers. The only reason I need a small screwdriver is to pry apart the switch. And the multimeter. Alright, let's perform a test right now. So the one I did last night, I know it works. I put it back and I know it works. So here's how we're going to test it. I'm going to put it on the beep mode. And what this is going to do is it's going to tell me if I've created a circuit. Now, the incoming power lines are the blue and the green. So what I want to do, on the switch, the blue or the green, it doesn't matter. I'll just use, for this purpose, I'm going to put it in the blue. Now, the switch is in the middle position. I touched the blue on this side. All I did was establish that there's no break in the wire. It's a complete circuit from this end of the wire to that end of the wire. I should not have a connection anywhere else. The other line is green. I should have nothing. The other 2 lines, I should have nothing, because the switch activates those. Now, if I move the switch in one direction, I will now have a circuit in one of these. There we go. And not the other one, as you can see. Now, and if I move the bolster, let's say I want to move the bolster out, now I'll have a circuit in the opposite direction. So this one should not have a circuit, and this one should. This switch works. Now, let's perform the same test on the switch that I just removed. I'll do the exact same thing. I'll put this in the blue one, and I should have a circuit on blue, and I do. So that tells me that this wire is good. If I'm troubleshooting, I can forget about that wire. I should not have a connection anywhere else. Nothing. Now, when I flip the switch like I just did on the other one, I should have no circuit. No circuit. I've not completed a circuit. Go the other direction. Nothing. I'm dead. I have, this switch is not creating a circuit. These are the output wires that go to the motors. So the blue and green are the wires coming into the switch, supplying power to the switch. The brown and the white are exiting the switch, sending power to the side bolster motors. Okay, we just established there's the one I repaired yesterday worked. You saw that. The one I just removed does not work. So let's take it apart. I'm going to turn off my multimeter to not kill the batteries. Alright, here we go. Here's where the small screwdriver comes in. So all I'm going to do here, there's 4 tiny little clips on each side. I found that I could go in, pry this up, and move the switch out with the screwdriver just a little bit. And if I'm very careful, I can turn the switch over, do the exact same thing on this side, and remove the switch. Okay, it just came out. There's now. Very important. There's pieces in here that probably will fall out, so be very careful. I've got a white pad. I'm going to remove my screwdriver out of the way. The contacts that create the circuit, they slide. It's a movable part that's going to come out. And then there's a pin and a spring also. So let's see what we've got here. There's the contacts. They are corroded, heavily corroded. This was worse than the driver's side. And inside of here is the pin and the spring. And I'm getting green crunchies out of here. I'm gonna just move the spring and the pin out of the way. I don't need them at all for this function. So there's nothing I need to do with this other than my nylon brush. And I'm going to move the switch to one side, and I'm just going to get in there and get the dirt out of there. And I'm going to move the switch to the other side so I can get access. Now, the little sliding contacts are heavily corroded. So I'm going to take my brass wire brush and just get down on the edges and the sides. Now I'm going to hit this with sandpaper, but I want to get down into the edges and sides right now. You want to get as much of that corrosion off there as you can. And why that's important is once something's been oxidized, or oxidizing, by the way, is more common with steel, but there are corrosions with non-ferrous materials like copper, and this has had an electrical corrosion or maybe moisture. So I've cleaned in between everything. Now I'm going to take some, I can't remember what this is, I think it's like an 800 or something, and I'm just going to slide it along there, turn it around so that I apply pressure evenly and wear this evenly on both sides. Definitely better, it's shiny. I'm just gonna hit this again with the wire brush. Now these, by the way, these are also spring loaded on here. These are spring loaded on here, and you can pry these off. I don't see any need to do that. I actually did that last night. I saw no reason to take that off. I was able to get this nice and clean with just my wire brushes. So this is a little bit rougher, and I'm going to hit it again. Oh, that did a good job there. And I like to, when I sand things by hand, I like to do it one way, and then I like to turn it around and do it the other way. And the reason that is unless you're very focused and concentrated, you're more than likely going to have uneven pressure when you're pushing. So you'll end up removing material from one side more than the other. At least by rotating it, you can somewhat keep it even, or you can just totally focus on what you're doing. Now I went to a little bit finer, and all I'm going to do is just smooth it out a little bit. I think this is a 12 or 1500 grit, and the reason smooth is important and not rough is because this is a movable part. So this slides over the contacts. The switch moves this back and forth, so it's, when it's in the middle, it's only touching two poles. So it's not creating a circuit on either side. So this, it's movable, it needs to slide. So we want to have a smooth surface so we don't have friction or galling. Plus, the more smooth it is, the harder it will be to build corrosion back up again. Okay, now for cleaning out in here where the contacts are, if you can see that, it's filthy in there. It's filthy. I'm going to actually use my steel one. I don't care about the plastic. I mean, you don't want to break it. You need to use a little bit of caution, but I really need to clean that up and scuff it up. And the brass one, it's just not going to be, it's not going to, the brass one's going to require too much effort. I don't know if you can see all the dirt that's ending up down here. Yeah, this switch is definitely worse than the driver's was. And by the way, these brushes, this is a very standard brush, bristles on one side. When I have the option, I like to get a brush that has this tiny little spot up here. It's better for getting, ouch, it's better for getting into the tight surfaces. Now my steel one's a little abused. I'm having a hard time getting into the corners. I'll just throw my brass one in there and see. Okay. Actually, that worked really well. I got it. So really quick before I move forward, I'm a big freak on clean work environment. So I'm going to get rid of all this contamination and wash my hands. I am going to put some dielectric grease in here, and the reason is because this is corroded once, it's going to corrode faster and easier, especially with roughed up surfaces that I've had now. I'm just going to try and slow the process down as much as I can. So I just put a small amount, just so I covered the surface. Okay, here's the assembly. So, spring. I don't have it on me right now, but this is where a magnetic tip screwdriver comes in. Very handy. The one I did last night, I had my magnetic tip screwdriver up here. I don't right now, so I just need to get lucky and get it in the hole. Okay. It's in there. Now, this, I may as well just put a dab of grease on here as well. Can't hurt. Okay. So, I like to set this on that dome part. Make sure it's sitting on there. So here's what's important. The contacts need to run this way, not this way. That's very important, or your switch will not work. Okay, here we go. Okay, the switch is in. Clean my fingers off. It's moving and springing back into place, which is what it did not do in the car. Let's bench test this. So I'm going to put this on my beep. I'll do exactly what I did last time, and I will put one of the wires in the blue. I should have a circuit on blue. I should not have a circuit anywhere else. I should not have a circuit anywhere else because at this point the switch is in the neutral position. Now if I engage the switch, look at that, connection, no connection. If I engage the switch the other way, now the other one should make a connection. This one should not, and this one should. Switch works. We're done. Now, while I'm here, I'm going to put some dielectric grease on the switch that I rebuilt last night. Okay, we're on the passenger side. I have not tested this switch yet. So here's what happened last night on the driver's side. When I put the switch in, the side bolsters still did not work, but I could hear the motor engaging. I had to keep toggling the switch, and what happened was it freed itself. So either the motor itself needs a drop of oil, or the linkage, it looks like it's one motor with linkage, or that either the motor or the linkage needs oil or grease. The motor is right up in here. The next time I take these seats out of the car, I will try to oil that motor. But let's see if we can get this to work. Okay, it's plugged in. Ready? Here we go. Oh yeah. Holy smokes. Out. In. Okay, once again guys, take a look at the bolsters. If you can see. Out. In. Out. In. This switch is in there nice and tight. I mean, it's not even moving. The switch is not moving at all. All I did was use a zip tie, and now I will just trim off the end.